Converting between entire radicals and mixed radicals. This is big. This is important. You're going to do this a lot. And especially with exact values, which you're going to do a lot. A radical expression is one that contains a radical sign. Well, that's a pretty radical definition. We often refer to them as radicals. Some examples are shown below. So, square root 80, cube root 32, 4 root 7, that's how I read that, 4 root 7, negative 10 root 15, and 2 cube root 16. Now, let's talk about radicals. They come in two forms, entire and mixed. Examine the table shown. The first column includes only entire radicals. Notice by an entire radical we mean just a number under the radical sign, and a mixed radical consists of a number in front and then a number under the radical sign. So what makes a radical an entire radical? It's a number under a radical sign. So it's only, I'm not a pen. It's only a number under the radical sign. And a mixed radical is a number in front and under the radical sign. Sign. Okay, so we're going to use our calculator. You're going to use your calculator. Find the value of each of the radicals in the table to the nearest hundredth. So I'll tell you what, I'm going to do a couple of these, but only a couple. Actually, you know what, one. I'm going to go, okay, 2. Root 80. Okay, calculator on, clear. Second, root 80. Enter. Oh, wait a sec. So look, we're doing this entire thing rounded to the nearest hundredth. Let's make life easy. Mode, down to float, over to 2. Enter. So what we're saying to the calculator is round everything to 2. Let's pull back that root 80. 8.94. 8.94. And we'll do one more. 2 cube root 4. 2. Okay, cube root under the math menu, number 4. So cube root and then 4. Enter. Notice it throws brackets around. It tells you it's 2 times the cube root of 4. 3.17. Okay, be we in class or we on doing this, then you are going to do this. So go do this, fill it in. I'll meet you back here. I'll have it all filled in. On your marks, get set, go. And one thing to note here, the equal sign with a dot on top means that it's approximately equal to, and because we are rounding, then that's what we're saying. This is approximately equal. Now, if you notice, we have, hey, like root 18 is 4.24, and so is 3 root 2. So we can go through our table and fill this in, that root 18 corresponds to a mixed radical of 3 root 2. Root 40 is 2 root 10. Root 80 is 4 root 5. The cube root of 32 is 2 times the cube root of 4. 2 cube root, don't forget the index. And 6.3, the cube root of 250 is 5 cube root 2. So it's kind of interesting. We have some mixed and entire radicals that are the same. Let's examine exactly what's going on here. And maybe at this point you start to see a bit of a pattern in there. So we need to be able to convert between entire radicals and mixed radicals, both ways. Entire to mixed, mostly what we're going to be doing, mixed to entire. But before we start, it's useful to know a few basic facts. So let's go through our perfect squares and the square roots. So basically we're just going to square each of these numbers, right? and it would take me longer to pause and begin than it would just to write these out, right? These numbers are the perfect square numbers because they have square roots. And we work with squares, we work with cubes. And so we're going to fill this in for the cubes. And I'm doing this from memory because I've worked with these a lot. But it'd be very handy if you knew these numbers as well. At the very least, you must know these. You have to know these, and you need to know that what these are. So if you see like 216, you at least recognize it as a cube root. Okay, mixed radicals. Always write in simplified form. We are going to convert each of the following into a simplified mixed radical. If we say mixed radical, it's simplified. We don't have to go beyond that. Square roots. The radical is simplified when the radicand contains no perfect square factors other than 1. So here's what we're going to do. We're going to look at the number here. We're going to write it as the product of two numbers, one of which is a perfect square. So 18 is 9, that's the perfect square, times 2. Okay, so all we've done is written 18, broken out, written it under the radicand sign as 9 times 2. We are now allowed to split that out and write it as root 9, root 2. And this is why we want a perfect square. Root 9 has a square root, which is 3 times root 2. And then it's written as 3 root 2. And it's pronounced 3 root 2. Next up is 40. So you're looking for the largest square that goes into 40. So let's back up here. Perfect square. Well, that's 4, right? 9, 16, any of those guys get too big. So 4 is the largest perfect square that goes into 40. So we write it as a product of. First number you're going to write is the one that has the square root. You're then going to write it as the product of two radicals. I usually don't put a time sign here. So root 4, root 10, and then 2 root 10. Now, you can get to the point where you just look at root 40 and you write 2 root 10, and that's fine. Actually, it's kind of where I'd like you to be after a little while, is being able to do that. But if you need to, this is how you split it up. So, negative the square root of 128. So the negative is just here out front, right? I mean, this really means negative 1 times the root of 128. When we've got 128 as a mixed radical, it just means there'll be a negative sign in front. Okay? So I'm just going to clear that away. We don't need that. Okay, we need the largest perfect square that goes into, so does 1, yes, does 4. But here's a hint, if 4 goes in, then maybe 16 goes in. So does 128, is that divisible by 16? 1, 2, 8 divisible by 16, and it is, and you get 8. Oh, I want to get out of the rounding here, so I'm going to go back down to float, hit enter. Right, and we're actually up a page. So we can write it as 16 times 8. So the negative sign, 16 times 8, the negative sign, root 16, root 8, and the negative sign, 4 root 8. Oh, but one sec, 8. 8 is 4 divided by 2. Or sorry, it's not, it's 4 times 2. So 8 is 4 times 2, and 4 has, or is, a perfect square. So this is negative 8 root 2. Now what that means is, if there's still a perfect square under there, that 8, and there's a 4 there, then really the largest perfect square that goes into 128 is really 64. So, sorry, interrupted, don't know what I was saying last. But basically, if 4 goes into a number, then maybe 16 does. Since 4 goes into 36, maybe 36 does, and maybe 64 does. So always try and check some other numbers, especially if 16 goes in, then maybe 64 does, right? If 4 goes in, then maybe 16, maybe 36. Just something to look for. Okay, so let's do this the efficient way. Negative root, so we're going to go with the largest, which is 64. 128 divided by 64 is 2. So it's negative root 64. We split the 128 into a product, right? Write it as a product of two numbers, the first one of which is a perfect square. Then we split the radical out, we get negative 8 root 2, which is this, right? And that's your answer. That's the one you have to end up with. But if you don't get there directly, you just have to recognize, oh, hang on a sec, I still have a perfect square here. I need to keep going. Speaking of keep going, let's do 2 root 75. So the 2 is just going to hang around out front. 75 is 25. That's the perfect square times 3. I mean, 75 is 5 times 15, but neither of those are perfect squares. So remember, you're looking for, back up, you're looking for a perfect square, right? One of these guys, 1, 4, 9, 16, 25, 36, 49, 64, 81, or 100. If it's not one of those guys, then you aren't going to use it. So that's 2 times, and now from the root of a product, it becomes the product of the individual roots. And this is the number 5, and 2 times 5 is 10, so we have 10 root 3. Cube roots. The radical is simplified when the radicand contains no perfect cube factors. So you're looking for the largest cube. Back up to 1, 2. Here are our cubes, right? These are the numbers we want to go in. 8, 27, 64. Look, it's interesting, 64. 125, 216, 343. These are going to be pretty big numbers if you've got 343 going into them. So if they're small numbers, then it's, probably one of these guys, right? Like 128, it'll be a 64, and so on. If you see 250, it's a 125. Okay, I'm not going to come back to this, but you have it in front of you. So, okay, so what do we do with 32? The largest perfect cube that goes into 32 is 8, and 32 is 8 times 4. That then becomes, this is what we call the root of a product. It's the cube root of a product. This is the product of 2 roots. So we split this up, 8, 4. The one that actually has the cube root, so the cube root of 8, so it's 2 times cube root 4, and that's written to cube root 4. And I might write things just a little differently. Okay. This is a negative, but we can do the cube root of a negative, so I'm going to go with the cube. The number is 27, so I'm going to make that negative 27. Let me just extend this out. And then we split it up into the product of, so the cube root of negative 27, the cube root of 2. The cube root of negative 27 is negative 3. I don't need the time symbol now. We'll just go negative 3, cube root 2. And your check is, does 4 have a cube root that goes into it? No. Does 2 have a cube root that goes into it? No. Cube root of 80, and the 3 in front, so the 3 just stays in front. And then the cube root, do not forget the index, or you will lose marks. And if you're handing stuff in early, then your rounding needs to be 100%. Your units need to be 100%. Your radicals need to be 100%. You cannot hand me in something early and you're missing units, or your rounding is incorrect, or you're missing the index here, right? You need to check through. Okay, 80 is 16 times 5, but 16 is a square, not a cube. And the cube is actually 8, so it's 8 times 10. You notice there's no perfect cubes that go into 10 because 8 is actually the first perfect cube. 3 stays in front. We now split the product of 8 times 10 into individual roots. The cube root of 8 is 2. And then we have cube root 10, and this is 6. Cube root 10. How do I know that's the same, you might wonder? Well, let's try this. So what do we have? We have 3 times the cube root of 80. Let me clear this. So 3 math, cube root is 4. 3 cube root 80, enter. And 6 math, 4 cube root 10, enter. See, these are both the same. That means that 3 times the cube root of 80 is 6 times the cube root of 10. That's a verification. You hand stuff in early, this better be right. Okay, and there are no perfect cubes that go into 10, so it's in lowest form. Okay, this time the negative is out front. We can actually then, oh, we're going to leave the negative out front. So we have negative cube root. I need a perfect cube. The largest one that goes into 250 is 125. Now you leave something like this and there's a problem. So we need to extend this out. Okay, so that the radical sign is over everything. Otherwise it becomes the cube root of 125 times 2, right? If it looks like this, then that's really the cube root of 125, and then multiply that by 2, and that's not what you want to get across. Okay, cube root 125, cube root 2, cube root, the negative. Look at that. Equals negative 5, that's the cube root of 125, cube root 2. Fourth roots, one moment please. Okay, the radical simplified when the radicand contains no perfect fourth factors. So think about fourth, right? So our fourth, 1 to the fourth is 1. You're not using that. 2 to the fourth is 16. 3 to the fourth is 81. None of our numbers are that big, so we're just going to go with these numbers. 4 to the fourth is 256, you know, and so on, right? You're going to get into this pretty big number. So 16 is a fourth, perfect fourth, right? It has a fourth root. 32, 16 times 2. Number that has the fourth root goes first. The fourth root of 16 is 2. It's 2 times the fourth root of 2, which we write as 2. Fourth root 2. Something's happening somewhere. Okay, fourth root. Again, you need an index, you need units, you need rounding, you need to be rigorous. 81 goes into 162. 81 times 2, right? Feel free to use your calculator. So it's fourth root 81. Fourth root 2, they're both fourth roots. The fourth root of 81 is 3. Fourth root 2. Again, you want to verify that, you know, so test is done, you got lots of time. Do the fourth root of 162, do 3 times the fourth root of 2, and you will find, okay, 80. Well, first fourth is 16, so is 80 divisible by 16? Yeah, 5 times. Okay, 16 times 5. So the 5 is out front. We split the product, the root of the product, into the product of a root. The fourth root of 16 is 2. And we get 10 times the fourth root of 5. moving on. Entire radicals. This is going the other way, right? So we want to convert a mixed radical to an entire. So let's deal with squares. Square roots. Any number can be written as the square root of its square. So 7 is the square root of 7 squared, right? You just have to square this number. I think of it, this 7 is the square root of 49. You cannot take the square root of a negative, so let's do this. So 2 can be written as the square root of 2 squared, which is 4. So we write this as the product of two radicals. This 2 is changed into root 4. We then bring them together, reversing the process, and multiply. And 2 root 5 is root 20. 5 root 10, 5 squared, 25. So we get root 25, root 10, which is the root of 25 times 10, which is the root of 250. 4 is the square root of 4 squared, which is 16. So we got, I don't usually, I don't write time signs like that. So I write it as, oops, also can't write with an eraser. Root 16, root 3, which is the root of 16 times 3, which is root 48. Negative. Okay, the negative just stays. Okay, we're not going to see, if we square the negative 3 and put it under a root sign, it'll become positive 9, and this whole expression will become positive. And we want it to be negative. And I am sure of that. I am positive that this is negative. Okay, 3 squared is 9, which is negative. That sign is still there. And now we bring these together under the radical sign. And we do 9 times 4. 9 times 10 is 90. 90 plus 9 times 4 is 36 is the square root. But wait, it's negative. So it's negative root 126. Okay, because this is negative, so this has to end up as negative. Cube roots. 7 is the cube root of 7 cubed, right? So we're going to cube 7, which is 343. So we have to know our cubes back on the other page, where you just have to be able to, cube the number in your calculator. So 2 cubed is 8, right? So the cube root of 8 is 2. Do we take the 2, we cube it, then we put it under a cube root sign. And then we bring them together under one radical sign, and we turn it into an entire radical. Okay, cube the 10, you get 1,000. Times the cube root of 4. We bring them under one radical sign, so the product of radicals is the radical of the product. End up with the cube root of 4,000. Since it's cubing, the negative can come under a cube root sign, right? It's still going to be negative. Negative 4 quantity cubed is negative 64 times cube root 2, which is the cube root of, we bring them together now, negative 64 times 2. Cube root of negative 128. Okay, 7, remember we saw that up top, is 343. That negative under there is fine because it's a cube. So 7 is the cube root of 7 cubed, which is 343, times the cube root of negative 3, which is equal to the cube root of 343. Now I'm doing this in brackets so I don't lose the negative, right? So I've got the negative 3 there. And that is the cube root of negative 1029, right? And remember, the cube root of a negative is negative, right? So we'll have a negative, or in this case, with the simplified, we can leave the negative underneath there. Either one is acceptable. Fourth roots. Any number can be written as the fourth root of its fourth power. 7 to the fourth I don't know what 7 to the 4th is, not offhand, right? So 7, we would have to go 7 to the 4th, and that's 2401. So this is really the 4th root of 2401. But 2 to the 4th I know. So if we want to write 2, we say it's the 4th root of 16 times 7, which is 16 times 7 under with 1/4 root, and see that's 1742, which is 102. 5, the 4th root of 5. So we need 5 to the power 4, which is 625. Times, I usually don't put that time sign there, so 4th root of 3. Bring them together under 625 times 3, and you're saying, wait, you forgot the 4th. Right, so there it is. And that is the 4th root of 1875. I was either studying history, maybe something happened. Negative, so we can't pull the -3. We can't take -3 and raise it to the 4th. It'll become positive, and we'll end up with a positive here. And we need to end up with a negative. So the negative stays in front. 4th root, so 3 to the 4th is 81. So the 4th root of 81 and 3 are exactly the same thing, right? But to get an entire radical, we have to turn that into a 4th root. So it's the negative of the 4th root of 81 times 10. Okay, this is pretty ambiguous the way this is written, so this needs to be extended out to remove any ambiguity, and it's the 4th root negative the 4th root of 810. Okay, real world. Determine the hypotenuse of the triangle shown and write, let's call that h. So we know that h squared is 6 squared plus 10 squared. H squared is 36 plus 100. H squared is 136. H is the square root of 136. Now, you're looking for the largest square that goes into that. So 4 goes into 136, right? Or, well, maybe, I don't know, let's try it. 136 divided by 4 is 34. Now, what goes into 34? Only 2 and 17, right? So there's nothing else. If 4 went in again, then it really means that 16 would have gone in, right? Like when we did 128 divided by 4, you know, if we'd have looked, we'd said 32. Wait, that means another 4 goes into that. So we really could have gone 128 divided by 16. And then we'd say, wait, another 4 goes into that. So we really could have done the 128 divided by 64. Okay, in this case. So it's 4 times 34. Let's pop up here. So that's root 4, root 34. And so the simplified radical form, and you're always going to simplify radicals. Anytime you do a radical, must be simplified, okay? Anytime, this point on in math, unless we say express a mixed radical, like take this and make it an entire, anytime you end up with a radical, you will always simplify. And there are units here, so that is centimeters. And because I have time, I can go back and fill in the units, which is exactly something that you will do on a test, because you will often have time at the end, so go back and check things over. Box has a length of root 5, a width of root 6, and a height of root 3. Determine the volume of the box. I'm not going to draw this, so volume of a box is length times width times height. So root 5 times root 6 times root 3. So we've seen that the product of individual roots is just the root of the product. So we can pull these all together underneath. And that's 30 times 3, which is 90. So this is the square root of 90. You notice what's happened, right? Each of these individually, there's nothing you can do, but because the 6 has a 3, right? 6 is 3 times 2, we now have this 9. And that's a perfect square. So it's 9 times 10. Extend. So it's root 9 root 10. And so it's 3 root 10 centimeters cubed, because it's a volume. We are finding a volume, and that's measured in cubic centimeters. 2 more longish lessons in radicals, but there's a lot to do. Rectangle is an area of the cube root of 54 centimeters squared. It's an area. If the length is 3, then determine the width. Okay, area of a rectangle is length times width. The area is the cube root, index of 54. No units, because we're working now. And that's 3 times W. So W is the cube root of 54 divided by 3. So, cube root 54. Well, are there perfect cubes that go into 54? 27 times 2. So W is cube root of 27 times the cube root of 2 all over 3. Cube root of 27 is 3, so it's 3 cube root 2 over 3. Cancel. Cancel. And W is cube root 2 centimeters. Notice, not written under the radical sign, which kind of extended out a little bit. So which means I'd like to pick that up and move it over, but that's not going to happen easily. So, last one. Surface area of a sphere. Surface area of a sphere is 4 pi r squared. Determine the value of the radius. Write the final answer in simplified form as an exact value in terms of pi. So we'll probably end up with a radical, and we'll end up with a pi. Not a for real pi, and we don't get pi day this year. 32 divided by 4 is 8, and that's pi r squared. So 8 over pi, well, that's what r is equal to, r squared. So r is the root of 8 over pi. Okay, well, we want to write the 8 as 4 times 2 over pi. And now we want to split that out. We want the perfect square. So I'm going to write this as 4 over 1 and 2 over pi. This has a square root. This does not. So it's 2 root 2 over pi, radical, simplified, exact value, terms of pi, centimeters, because that's a radius. Dunometers. Okay, so these get a bit longer, just radicals of roots and powers, radicals, extraordinarily important. You're going to be using them throughout high school math.